Merci. First, let's do something about the sound. This is technical. There are two microphones here. Tell me which is clearer, right now when I'm talking like this, or if I turn that away. Is it? Just applaud when it's better. Is it better now? Or is it better now? Okay. All right. Welcome. For those of you watching on the web, we are at the University of Geneva, Switzerland, not Geneva, New York in the US. This is the Ig Nobel Show. My name is Mark Abrams. I'm the editor of a magazine called The Annals of Improbable Research. This is the magazine, and we are going to demonstrate to you our traditional method of distributing the magazine. We think of that as being the opposite of Swiss efficiency. I want to begin by thanking the University of Geneva for inviting us and the many people at CERN for co-sponsoring this and making this possible. All right. We have several people here. I'm going to ask each of them to stand up quickly, simply so you see who they are, but you will meet them later. This is the order in which you will see them. I'm going to talk first, and then you will meet Maria Ferrante, and Alice Martelli, then Stefan Bolliger and Stefan Ross, Bart Knowles. You will again, at that point, meet Maria Ferrante and Alice Martelli. You will meet them twice. You will never forget them. And our final speaker of the night will be Kees Muliker. Now we'll begin. I'm going to show you lots of pictures. Everything that we're going to talk about tonight is about things that make people laugh and then make them think. This is things, people, achievements that have that quality, that when you first encounter them, they're funny. And a week later, you find that that thing is still rattling around in your head. And all you want to do a week later is tell your best friends about it. Those are the things that we look for, things with that quality. We give out something called the Ig Nobel Prizes every year. And actually, I'm going to step back here because I'm wondering if somebody was up here playing with the keys first. So let's see, you don't need that, you don't need that. I have a little video to show you. It's short. I will not explain it beforehand.
Ontario. Hi, good morning.
Good morning, how are you?
Fine. This time you've done it, eh?
Well, it's taken a while, but like you say, yeah, finally we got there.
Because you and I have talked a couple of other times.
Yes, we have, a couple other times over the years.
But this is the suit.
Yeah, this is the suit. $100,000 later, 7 years of research, we finally got to a suit capable of doing what we want with regards to grizzly research.
What uphill is going to be very, very difficult. The log is going to want me.
Are you ready, Troy?
I'm ready.
Here it comes.
You okay? Mm-hmm. I got it. How'd that one go?
Better than the first.
I hope you will agree with me that that deserves some kind of prize. It's a man named Troy Hurtubise. Troy is from a small city in northern Canada. Troy spent 7 years building, and as you can see, personally testing a suit of armor that he hopes will protect him against grizzly bears. We gave Troy an Ig Nobel Prize. No matter what opinion you may have formed up until now, I want you to think about one fact. Troy spent 7 years doing things like this. He is still alive. All right, now we'll talk about the Ig Nobel Prizes and improbable research. Again, the Ig Nobel Prizes are for achievements that make people laugh and then think. Every year since 1991, we have given out 10 Ig Nobel Prizes for things that have that quality. If you win an Ig Nobel Prize, you win an Ig Nobel Prize. These are handmade. Every year the design is different. What's common across all the years is that they're made always of extremely cheap materials. We get something like 9,000 new nominations every year for Ig Nobel Prizes. We give out only 10 prizes. Consistently, every year, somewhere between 10% and 20% of the nominees are people who nominate themselves. Those self-nominees almost never win. We have a policy in most cases that when we select somebody to win an Ig Nobel Prize, we get in touch with them very quietly. We offer them the opportunity to decline this great honor. If they want to say no, that's okay. If they say no, that's the end of it. We never tell anybody. I'm happy to report that almost everyone who is offered an Ig Nobel Prize decides to accept it. If you do, you win a prize. You also win a piece of paper that says you have won an Ig Nobel Prize. This piece of paper is signed by several people who have Nobel Prizes. It's a nice piece of paper to have. There is a tradition among many of the winners, a tradition they started themselves, that they will usually take this home and have a very nice frame made. Usually they frame it under glass. They hang it in their home right above the toilet. The third thing you get is an invitation to come to the Ig Nobel Prize ceremony. This happens in the United States at Harvard University, happens in September. In this building, it's the biggest meeting place at Harvard, fits 1,100 people, it's always filled. The audience buys tickets and they come from around the world. That's what it looks like if you're up on the stage. And up on the stage, waiting to greet the Ig Nobel Prize winners, to shake their hands, to hand them their prizes, are some Nobel Prize winners. The year we took this picture at the start of the ceremony, we had 9 Nobel Prize winners on stage. So it's an interesting mixture of people that night. And the winners are kept secret until that moment. It's an awards ceremony, so we always used to have the same problem that every ceremony has. You know the problem. You have suffered from it. There are many people who are asked to give speeches. Everyone is asked, please keep your speech really short. You know what happens. Nobody does. It's a long night. We solved that problem 13 years ago. We solved it this way. Every year, we recruit a really cute little 8-year-old girl. We call her Miss Sweetie Poo. Miss Sweetie Poo sits on the side of the stage. At the beginning of the ceremony, I introduce her, and I explain that whenever Miss Sweetie Poo feels that somebody has talked long enough, she will let them know. And I ask her to demonstrate so everyone can see how this works. This Sweet, cute little girl walks across the stage. She walks up to the person who's at the microphone. She looks up at that person and she says, "Please stop. I'm bored. Please stop. I'm bored. Please stop. I'm bored. Please stop. I'm bored." She doesn't stop until they do. And it works. This photograph was taken at the beginning of the most recent Ig Nobel ceremony. We also used to have a problem that the winners would come from around the world and they were tired and dazed. Some of them had been on airplanes for 2 days coming from Australia and other far-off places, and sometimes they would be confused and wander away. We don't want to lose them. We need them on stage. So we noticed what was going on around us at Harvard University, where there are tours. There are tourists there all year round. We noticed that the Japanese tours had solved this problem. Japanese tours often had a rope, and they had everybody there hold on to the rope, or they tied them. So we decided to do the same thing with our Ig Nobel winners. And it works. We never lost one. All right. Here, very quickly, is a look at the most recent group of Ig Nobel Prize winners. We gave a prize in the field of psychology. The Ig Nobel Psychology Prize went to 3 scientists from the Netherlands, Peru, Russia, and they all live in the Netherlands. They were honored for doing a study called "Leaning to the Left Makes the Eiffel Tower Seem Smaller." This is their paper. They published it. You can go look this up and read the details. "Leaning to the left makes the Eiffel Tower seem smaller." We had this demonstration on stage with some of our famous scientists. This is one of the winners. This is Tulio Guadalupe. He flew from the Netherlands over to the United States to give his acceptance speech. He's holding up a picture of his 2 colleagues. His 2 colleagues very much wanted to come to the Ig Nobel ceremony, but they could not come because they had already planned to be somewhere else. They had to go to a wedding in the Netherlands 2 days later. They were getting married to each other. They got married, and after the wedding, they sent us this photograph. And they sent us this photograph. The Ig Nobel Peace Prize. Many people consider the Peace Prize to be the most prestigious of the Ig Nobel Prizes. And I feel a special quality even talking about it here in Geneva, the city where so many important matters of peace either were made better or were made much worse. The Ig Nobel Peace Prize last year was awarded to the SKN Company of Russia. I expect that nobody in this room has ever heard of the SKN Company. I believe even in Russia it is not well known. The SKN Company won the Ig Nobel Peace Prize because they convert old Russian ammunition into new diamonds. They do this by exploding the ammunition. The explosion, the way they do it, makes microscopic diamonds. The president of the company flew from Russia to the US, and here he is giving his Ig Nobel speech. He's holding up a diamond, but that's a big one. That's not one of the diamonds they made. This was just for show. You may notice this unusually dressed person next to him. That's one of our human spotlights. We always have 2 of them on stage. They illuminate the proceedings. The concept of human spotlight was invented by the other human spotlight. He's not in the picture. His name is Jim Brett. He's an engineer who has a PhD from MIT, the Massachusetts Institute of Technology. And 20 years ago, he invented 2 things in his life, 2 important things. One is he invented this concept of human spotlight. The other is you may be aware of something called 3D printing, 3-dimensional printing. Jim Brett is one of the people who invented that. But we feel this may be the better of his 2 inventions. We gave a prize in the field of acoustics, the study of sound. Went to 2 researchers from Japan. They were honored for creating a machine they call the speech jammer. Speech jammer disrupts a person's speech by making them hear their own spoken words at a very slight delay. Here are the 2 inventors at the ceremony demonstrating how it works. It's very satisfying. The Ig Nobel Prize for Neuroscience, the study of the brain and the nervous system, was awarded to 4 scientists for demonstrating that brain researchers, by using complicated instruments and simple statistics, can see meaningful brain activity anywhere, even in a dead salmon. They have a paper. Are some of you familiar with this paper? Okay. And are those of you who are familiar or you are brain researchers yourself? Some of you are, some of you aren't. I probably should explain a little bit. In the field of brain research, which is a big field with many people doing many different things, these days it's become very popular to use MRI machines that produce these beautiful images you've seen of the brain with parts of it lit up in colors. And that's what these people do. They were aware that there's been a problem in their field, that what you're seeing, this equipment is complicated, there's a lot going on. So it's not, what you see is not necessarily what you think you see. What's being measured varies. Sometimes it's electrical discharge, sometimes it's flow of certain chemicals. But the machine is interpreting that flow, turning it into a number, and then turning that into a little picture where everything is on or off. So you're seeing little pixels, little bits of light or dark. And if there are statistics, there are very careful statistics that you can use to make sure that that's interpreted in a way that makes sense. Because if you don't do that, there's lots of random noise in this system, and already it's doing something that's about 4 levels deep. So it's very complicated what's going on. You need these statistics to make sure you're not fooling yourself into seeing something that's not there. In that field, there's been a big problem that many people were not careful. To demonstrate that, these researchers went to the store. They bought a dead fish, a dead salmon. They put it inside the MRI machine, and they applied exactly the same test that many of their colleagues do. They used exactly the same procedures, and they explained in their paper, we are now going to interpret this exactly the same way our colleagues interpret their experiments. And what they did in interpreting it the same way those others do is they pointed at the little bits that are lit up. You see those red bits. And they said, following the same methods our colleagues use, we can say for sure that there's a tremendous amount of brain activity in this dead salmon. This dead salmon is thinking. All right. So that's what they were up to. Here they are at the Ig Nobel ceremony receiving their Ig Nobel Prize from a Nobel laureate. We gave a prize in the field of chemistry last year. We usually give an Ig Nobel Prize in chemistry. Went to Johan Peterson, who's from Sweden and Rwanda. He was honored for solving the puzzle of why in certain houses in the town of Anderslöv, Sweden, people's hair turned green. He traveled to the Ig Nobel ceremony and gave an acceptance speech. And you see Miss Sweetie Poo there, ready to help him finish his speech. In fact, if you look carefully, you see 2 Miss Sweetie Poos. This year, when we went looking for our new Miss Sweetie Poo, remember, they keep growing up, and she has to be 8 years old. So many years, we need to find a new one. And this year, we found 2 little girls who were both so good. I don't know if you have the expression in French, ice water in her veins. In English, we do. It means she's so cool, nothing can disturb her. We found 2 little girls who have such wonderful ice water in their veins that we could not resist. We had 2 of them this year. The Ig Nobel Prize for Literature went to the United States government's General Accountability Office. This is a big national government department. They won the Literature Prize for issuing a report about reports that recommends the preparation of a report about the report about reports about reports. You do understand what I have just done is give you a report about the report about reports about. This is the report itself. This is the very beginning. It's a long report. It's a very long report. This is only the very beginning. I have read the entire thing. I can assure you the whole paper is just as interesting to read as this is. The Ig Nobel Physics Prize was awarded this year to 4 scientists who calculated the balance of forces that shape and move the hair in a human ponytail. They published 2 papers. One of them is called Ponytail Motion. The idea for that was born when one of the scientists, Joseph Keller, was walking along the campus of his university one day, and in front of him was someone with a ponytail. And he noticed that the person the body, the head were moving up and down like this, but the hair was moving side to side. And he started to wonder, how does that work? What is the physics that turns this into this? That's where that paper came from. The other paper was doing something different. It was measuring the hair when it's not moving. It was measuring what happens when you have all of these individual hairs made of what hairs are made of. What are the chemical properties at work here and the physical properties? And it explains, by making a mathematical description, they were able to see that there are only certain shapes that a ponytail can take in nature. Okay? So when you recognize a ponytail, it's no accident you recognize it. I would like to ask if there are some people here with ponytails, if you would mind simply standing up and turning around so we can all admire the physics. And I would like to point out that this gentleman in green works at CERN. This is a live, genuine physicist with a ponytail. And I met him this week. He's a very nice person, and I apologize for taking this liberty, but I feel sure after this show is over, if you go up to him, he will explain to you the physics of his ponytail. Here are the scientists who did this work at the Ig Nobel ceremony, again with Miss Sweetie Poo helping them to finish their speech on time. We gave a prize this year in the field of fluid dynamics, what happens when things flow. Went to 2 scientists who studied the dynamics of liquid sloshing. Liquid sloshing, it's a funny word, sloshing. It is a technical term. Sloshing, I don't know what the French is, but it means it goes back and forth in a very sloppy way. So they studied how that works about one special thing. They studied that to learn what happens when a person walks while carrying a cup of coffee. And here's their paper called Walking with Coffee, Why Does It Spill? What they discovered, that the physics of this, the way coffee is, the way a cup is, the way our bodies are, the way we walk, all of this, the way the universe is built, makes it a very difficult thing to carry a cup of coffee and not spill it. If you spill coffee when you walk with it, you may think that's because you're a klutz. You may think it's because you're an uncoordinated person. And maybe you are. But even if you're not, even if you are the best athlete in the world, it's still a difficult thing to do. Now, I have a cup of coffee here. This is genuine coffee provided by the University of Geneva. And I would like to ask for a volunteer to come up and demonstrate what it's like. Yes, if you... Okay.
I must say, while going here, I spilled tea on myself.
He says he spilled tea on himself. Congratulations. Now, before you do anything, first could you just gently sip and make sure it is coffee?
It smells like coffee.
Okay, great.
Yes.
And if you would stand over here, hold it in front of you as far as you can, and when I tell you, walk, don't trip over that, but walk all the way across to the other side. And I'm going to just add a little sound to make this a little more interesting. So, wouldn't mind? Go ahead. And if you could walk a little rapidly, please go. Okay, that was good. Didn't spill too much. Now, that's not the only way people carry coffee. If you could just stand right there. Does anyone here have a book or a magazine that I could borrow? Could you? Oh, perfect. Could you bring that up? Great. Thank you. Okay. Okay. You probably have done this. You walk while carrying it down. If you wouldn't mind putting that under that elbow. Yes, the same one you're carrying the coffee in.
And have it like...
This klutz word that I...
Can I have it like this?
No.
Yeah, I have to...
Like that, yes.
Okay.
Yes. And if you could walk from that... Not until I ask you to begin. Walk from that side to that side. And if you could walk at twice the speed you used before. Please. Wow. You drank some more coffee, didn't you? Great. Thank you very much. Anybody like some coffee? Okay. Oh, you'll verify this. If the coffee comes up only to here, have some coffee. Next time we've got to remember to fill it all the way up. All right. Anyway, here is the chief scientist who did that work, giving his Ig Nobel acceptance speech. We gave a prize this year in the field of anatomy, the study of the body and the parts of the body. Went to Franz de Waal and Jennifer Picorni. Some of you know or know the name of Franz de Waal, and those of you who don't can ask those of you who do. They were honored for discovering that chimpanzees can identify other chimpanzees individually from seeing photographs of their rear ends. This is their study called Faces and Behinds, Chimpanzee Sex Perception. There are two photographs here. One is the face of a chimpanzee. The other is the rear end of a chimpanzee. Okay. I am not a chimpanzee. I am not qualified to tell you whether those two photos are from the same chimpanzee. Next photo shows the two scientists at the Ig Nobel ceremony giving their acceptance speech. Okay. I apologize to you. I have only this photograph of them. I do not have a photograph. Well, I have only a photo of their faces. And finally, last year, we gave an Ig Nobel Prize in the field of medicine. It went to two doctors from Paris, France. They were honored for advising doctors who perform colonoscopies. I should check that everybody knows that word, colonoscopies. It's a technical word. Are there people here who are not quite familiar or comfortable with that word? Two separate questions. You can be familiar, and I'm very not comfortable. Colonoscopy is when a doctor, we hope it's a doctor, examines the inside of your colon. The colon is the bottom part of your digestive system. It's where the waste collects before the waste exits the body. And they do this by sticking a tube up inside your body and a source of light so they can see what's going on. And usually they'll also put some sort of air in there so it expands the space so they can see it. That's colonoscopy. Would anyone here who doesn't mind answering this question, just raise your hand. Who here has had a colonoscopy? Okay. Now, who here would like to have a colonoscopy? All right. Let me tell you what they won their Ig Nobel. These two doctors in Paris won their Ig Nobel Prize for advising other doctors who perform colonoscopies how to minimize the chance that their patients will explode. From the reactions of some of you, I'm guessing you think this does not happen. It does happen. And when colonoscopies were new, it happened not a lot, but it happened a lot more than people wanted. Let me just explain why. In the 1950s, colonoscopies became a common medical procedure. The equipment was at that point better and the techniques had gotten better. But in the early days, there were some patients, not a tiny number, but not a giant number, but there were patients who exploded. Consider what's happening here. You have a patient who really has a tube inside. This tube is collecting waste materials that are producing gas, methane gas mostly. Methane gas, if you hold a match to it, it will catch on fire very easily. So you've got a tube filled with methane gas. The doctor inserts another tube in here, and in order to see what's going on, puts some light on it. In the 1950s, any source of light was also a source of heat. So you're introducing a source of heat into a closed tube that has methane flammable gas. Not only that, because the tube is thin and pressing on itself, the doctors always want to expand it. So they insert extra gas of their own. So it's like a balloon, so there's room to look around inside. Now, at the beginning, there was no history of this. There were no good guidelines. And some doctors thought, well, oxygen is a gas. And they put oxygen, added oxygen to the methane, and then added heat. This is a perfect recipe for an explosion. So that's how patients exploded. They quickly learned don't use oxygen. They use other gases. But even so, even now, sometimes it happens. It happened to these doctors, and they wrote some advice for others. They wrote several papers. One of them is called Colonic Gas Explosion during therapeutic means we're doing something to make you better, colonoscopy with electrocautery. That word electrocautery probably is not familiar to all of you. It means they're introducing something very hot. They're burning something. If you have an extra little piece of skin or something, they will burn it off. So you can see they're introducing intense heat into this atmosphere. So now you know how these explosions could happen. It happened to these doctors. They wrote some papers so that nobody else would do this, they hope. The man on the left is one of the two doctors. He flew from Paris to Harvard to accept his prize. This is moments after we announced him. Now, remember that we keep it a secret until that moment on stage. We keep it secret who the winners are and what they did. We announce it, I announce it. The winner steps through a curtain, and there is a Nobel laureate waiting to shake his hand and hand him the prizes. That's what you're seeing. That's Roy Glauber, who has a Nobel Prize in physics, shaking the hand of the man who did the colonic explosion paper. Now, keep in mind, Roy Glauber, only about 15 seconds before this picture was taken, learned who this man is and what he did. Look at the expression on Roy Glauber's face. And I want to tell you about just one other past winner before we get to the other good parts of the evening. We gave a prize in the year 2000 to two physicists. And they're both two pretty big names in the world of physics, Andre Geim and Michael Berry. We gave them an Ig Nobel Prize in physics because they used magnets to levitate a frog. They used magnets to levitate a frog. And we have video of this. That was in the year 2000 that we gave them the prize, and Andre Geim came to the Ig Nobel ceremony. 10 years after that, 10 years after Andre Geim was awarded an Ig Nobel Prize in physics, he was awarded a Nobel Prize in physics, not for doing this. All right. And before I finish, I want to tell you a few things that are new about what we're doing. This is a really big year for us at Improbable Research. Several very good things have been happening to us, and some of them we started, some of them have been a happy conjunction of circumstances. For one thing, we have just begun producing the magazine not just in paper, as you saw the paper version. We've also, as of a few weeks ago, have begun producing every issue as an e-book. And I understand e-books have not yet become very popular in Switzerland. They will. In the rest of the world, country by country, they are becoming the dominant way that a lot of people read books. And we are the first magazine in the world to publish as a standard e-book. So you can go to Amazon.com or many of the other places and buy them. And if you want to try one, you can get a free issue on our website at improbable.com. There's lots more at improbable.com. You can see a list of all the Ig Nobel winners and links to their work and videos of some of them. Also, I have a new book out called This Is Improbable, and it's about a lot of these things. I also write a newspaper column regularly in the British newspaper, The Guardian, and a lot of this comes from the newspaper column. I would like to introduce somebody very special who's in our audience who invited me to write for The Guardian 10 years ago. He's the former science editor of The Guardian, one of the best writers on earth, Tim Radford. And I would like to publicly thank him. Tim has some wonderful books. This is one of the best writers who ever lived. Okay, look at him. Okay. And the other good things that have been happening have been building up over the past year, all involve television. Working together with a French television company that we are now having a series of television documentaries made about the Ig Nobel winners. The first one was shown on France 5 a few months ago, and the rest will be produced soon. This is a picture from the beginning of the first documentary. The fellow at the bottom there is sitting in the front row. You saw him briefly, Bart Knowles, if you would just stand up and turn around so they can see your face and verify that it's the same person. Bart is demonstrating what he did there, but he will explain in more detail in a few minutes. You'll get to meet him. And we're excited about that. We're also excited because beginning this year, the Ig Nobel Prize ceremony is going to be televised live on television networks around the world. And I hope it will be televised here in Switzerland, and I hope wherever you are, you'll be able to watch that on September 12th. And if you're near Cambridge, Massachusetts, come to the ceremony. And also, starting next year, a third television project. In the Ig Nobel ceremony, the highlight of the night is the 10 times we announce and introduce a new Ig Nobel winner. But in between those moments, we do other things. One of the things we do is every year we write a little opera, a funny opera about something in science. We steal the music from old operas. And we're going to take 13 of those and make them into a television series, again, working with these wonderful French TV people. So that's coming in the future. That's what I've had to show you about this stuff. And now we are going to, here's what we're going to do the rest of the night. We have our opera star here tonight who will sing you a song now from one of the Ig Nobel operas. She will sing you a second one later. And we have discovered an amazing, wonderful young pianist and accompanist from Italy who has been kind enough to join us today. I'd like to ask them to step up and prepare. Please welcome Maria Ferrante and Alice Martelli. Let me get this. I'm going to show you the words to this. This is one song from an opera that was about the Big Bang. Show you the first words here. So I need to start. Wonder if our technician can race down here and do something?
And they're not all the same.
And they're not all the same. All right. While we're fixing this. This opera was about the history of the universe, the Big Bang and the formation of galaxies. This song is sung by a galaxy. This may be the only time you ever see a song sung by a galaxy. Certainly the only time you've ever seen or will see a song sung by a galaxy who is a soprano. At this moment, she sings this song because she's a little upset. The other galaxies have been behaving like teenage children, like beautiful teenage girls who are gossiping. They're gossiping about the most beautiful galaxy in the universe. They're saying nasty things about her, the way sometimes teenage girls say nasty things about other teenage girls and write notes about them. And she's heard the gossiping, and she's going to tell you about it, about what she thinks. How are we doing? We're not doing well. Well, I'm going to do it. You'll see part of the words.
Sorry.
Okay, thank you for making that valiant attempt. And I'll try to keep up. But if I get confused with this, ignore that. Please pay attention to them. Right. So you've just heard what's happening. Here we have the most beautiful galaxy in the universe explaining her upsetness at this.
What?
Maria Ferrante, Alice Martelli, now we're going to have a series of talks, short talks by genuine Ig Nobel Prize winners. They've all traveled great distances to be here today. Each of them will talk for 10 minutes and then take a very few questions. Now, we do not have the little girl with us, so we're going to use a different method to assist them in finishing their talks on time. To do that, I'd like to ask for 2 volunteers who would not mind sitting up here and helping us, just assisting us. Are there 2 volunteers who could help us? We need one person who knows how to tell time and who has either a wristwatch or a clock of some kind. Is there somebody? Yeah. Do you mind coming up? Thanks. And we need somebody else who doesn't need to tell time at all. Okay. Yeah, if you could come up, please. Great. Okay. And you can get seconds on that, not just minutes. Okay, come on up. I have your equipment waiting for you. Sit right here.
No one said anything about a bell.
Is there anyone here who does not have a phobia of bells? Okay, here's your bell. All right, here's the way it's going to work. All right, yeah, here's the way it's going to work. They have each speaker. We're going to begin with 2 people who are a team, but each of them has 10 minutes to do their talk. So please pay careful attention to when they begin. We're going to notify them every 2 minutes. Okay, at 2 minutes, at 4 minutes, at 6 minutes, 8 minutes, and 10 minutes. Here's how we're going to do it. When there are 2 minutes that have gone by, please notify the man with the bell. Do that by tapping him twice. Yeah, maybe you could do it this way. Okay. And when you are tapped, then please hit the bell that number of times. So we could rehearse this for the first time. Well, let's start from the first. So after 2 minutes, you do. Okay. After 4 minutes.
Are we doing 2 or are we doing 4?
4 minutes, please.
Yeah, but are we doing 2 or 4 hits?
4.
2 hits.
4 minutes, 4 minutes, 4 hits.
4 hits on the bell or 4 hits to me? I'm afraid I'm going to lose track. Right.
Wait. Are you a student here? I'll leave you alone on that. All right. 4. He'll hit you 4 times. You hit that 4 times.
4 times? 1, 2, 3, 4.
Okay.
Okay. Okay. After 6 minutes. Okay. 6 minutes. 6. Very good. After 8 minutes. 8 minutes.
Okay.
Okay. And after 10 minutes, you hit him. Please listen. After 10 minutes, hit him 10 times. When he hits you 10 times, you start ringing the bell and do not stop.
Okay.
All right. That's how we're going to work things here. Let me close this. Okay. Good luck to that. Okay. Our first set of Ig Nobel winners have journeyed down from a distant land known as the north of Switzerland. They won an Ig Nobel Prize for doing some research. They published on it. They worked very hard, and they came to a definite conclusion. I will ask them and allow them to explain what they did, and if they wish, also why they did it. They're both now based at the University of Zurich, that's correct. Please welcome Stefan Bolliger and Stefan Ross.
hope you can see it. A long, long time ago, we heard before about big bangs and galaxies. The universe evolved, and out of the primordial goo, life decided to evolve and then continued, developed vertebrates, walked upright, decided to become a primate, and invented trivial things as, for instance, fire and tools. But if you have a fire and you have tools and you're cooking meat over the barbecue, what's the point of doing that if you don't have, for instance, a beer? So the pinnacle of evolution, as to date, is obviously also the portable beer. Cheers. It's warm. Well, if you look at the shape, it reflects where we came from the caves, with bats, with bludgeons, hunting mammoths or whatever. If you look at the shape, the similarity is striking. You can really hold such a bottle and then use it as a club, either to fight in a bar or to settle academic disputes. It doesn't hurt that much. We were asked by the court, in a real case, whether hitting somebody with a beer bottle can inflict serious harm, crack their skull, and if so, what's more dangerous, the empty or the full bottle? So we decided to perform a simple experiment. No, we didn't get a whole lot of students. Unfortunately, they're a protected species. Instead, we measured the stand beer bottle. We looked how people hit with this. Thank you. 2 minutes. My goodness, you must be a mathematician. Half a litre of lager beer, weighs empty almost 400 grams, full 900 grams, and is refillable. Refillable because one of Stefan Ross's tasks in our study was also to make sure that these bottles were also emptied. Stefan is also a radiologist. There are many ways to measure the thickness of a bottle wall. We decided on using the most simple and cheap method. We scanned it in a CT. As you can see here, wall thickness ranged between 0.2 and 0.36 centimeters. Perfect, isn't it? I mean, 0.0. That's exact, isn't it? Then, instead of using students, we dropped a weight from a certain height onto these bottles. Here, with this contraption, we could release it. And as a simulant, we used a bit of wood and plastiline to simulate the skull and the scalp. And then, here in this baby bath, let the bottles burst. Here you see the weight. 4 minutes not over yet? You forgot, huh? Well, what happened? Apart from Stefan emptying the beer bottles and getting more full, the full beer bottles remained intact until about 25 joules. The empty, they broke at 30 joules, and obviously in excess they always broke. The empty beer bottles were far sturdier. They only broke at 40 joules. None of them broke at less than that. So, what can we say with this huge and very cost-intensive experiment? You didn't forget me. Was that empty bottles are more sturdy. So, what's the matter? If you compare this to the fracture threshold of a skull, the energy needed for a human skull to break, you can read that the skull fractures, depending on the impact region, between 14 and almost 70 joules. If you compare that to our bottles, you see, that's computers for you, isn't it? These here would be the full bottles, the empty bottles, and the human skull. So definitely, these bottles suffice to break the human skull. The empty ones as well as the full ones, although the empty ones can break more regions of the skull than the full ones. So, to conclude this, not finished yet, empty bottles are sturdier, both suffice to break the human skull, and beer bottles are formidable, potentially dangerous weapons. So my take-home message to you tonight is drink the beer empty first so you have more fun, and then argue later. Cheers.
Okay. Doesn't matter. We have time for just a few questions. Could you please stand up and scream your question? Yes, you in the white. We couldn't quite. Did you hear that?
The question was whether an empty skull is sturdier. Well, we definitely need a few students now.
Next question.
The full bottle...
Could you repeat the question?
Why does the full bottle break at a lesser energy than the empty one? Well, the empty bottle doesn't have anything inside apart from air, and the full bottle has an incompressible fluid, which is also carbonated, so it stands under pressure. So as soon as another force is applied to the wall, then it will burst easier. Beer, the question was whether the beer was carbonated. Do you know of any beer which was not carbonated?
Does it have a cap on it?
A cap, yes, yes. The question is very good indeed. We asked ourselves too whether we should try this with or without a cap. But if you hold a bottle like this and whack somebody on the head and you don't have a cap on, then you very soon will have an empty bottle and wet trousers.
And a question related to that question. Did the people have caps on or not?
I'm
Don't
not
answer
sure about that.
Don't answer that. Okay, one final question. The woman in red in the back.
The question was whether we compared other types of beer bottles. Work is in progress, but Stefan isn't quick enough in emptying the bottles.
Stefan Bolliger, Stefan Ross. Thank you. If one of you happens to have a mop, we would be grateful if you would bring it down here. Our next speaker won an Ig Nobel Prize in 2006. He has come here today from the Netherlands. His name is Bart Knowles. He has a continuing series of adventures. He has not enough time to begin to tell you all of the things that led up to this and that have resulted in the years since he won his Ig Nobel Prize. But I believe he's going to tell you mainly what he did and why he did it. Please welcome Bart Knowles.
We have to have the start. Right from the start. Okay, as he is preparing,
let's go to system preferences. Here.
So I'm asking you all kindly to stand up. Can you please stand up? Thank you. And this is not part of my talk, by the way. Okay, it's not part of my talk. So I'm going to ask you. I'm a biologist, and I'm always doing experiments on and with people. So I'm going to involve you in a tiny little experiment this evening. The question is very simple. If you, this morning when you dressed, if you put on a fresh pair, clean pair of socks, then remain standing. Otherwise, you sit down. Okay, you don't understand what I'm saying, okay? Okay, good, good. I'm doing it the other way around. If you put on clean socks this morning, if you put on clean socks this morning, you remain stand. No, sorry, you sit down. Sit down. Ah, good. Come on, be honest with me. Be honest with me. Be honest with me, please. Okay? This is a real experiment. My next question to those of you, everybody's looking, who didn't, ooh. For those of you still standing, if you put on clean socks yesterday, then you sit down. Be honest with me. Be honest with me. Oh, I've got two that don't wear socks. No, outliers in my experiment. Just sit down. Okay. 1, 2, 3, 4. I've got 4 standing. Did you ever put on clean socks? Okay. Well, I'm going to talk. You can sit down now. Everybody will smell you, I think, from a distance. Very good. So I'm intrigued. I'm intrigued in the smell of human beings. And why am I intrigued in the smell of human beings? It started 3.3 million years ago. It started in Ethiopia when Lucy, one of our ancestors, Australopithecus afarensis, when she stood up and she started walking in the savannah. And then something dramatic happened. She got a disease. She got smelly feet. She started suffering from foot odor. And there was one animal that took a big advantage of this, and it's this animal, the most dangerous animal on the planet. This animal kills more people than any other thing in the world. This is the African malaria mosquito, Anopheles gambiae, which kills approximately 1 million people every single year. And this is exactly what I'm trying to overcome, and I'm trying to stop. That's my job. That's what I do for a living. Now, what I tried to do during my PhD is to find out what smell from human beings African malaria mosquitoes use at night to find you. They're flying out at night, and what do they use in terms of your smell that makes them attracted to you? The problem with us humans, is that we are the biggest stinking primate on the planet. We smell much worse than gorillas or chimpanzees, mind you. I don't think many of you have smelled a gorilla or a chimpanzee, but believe me, we are the worst stinkers on the planet. We produce more than 300 different chemicals on our skin, and we exhale more than another 100 chemicals from our breath. And my task was to find out which are the compounds that she uses. Now, mosquitoes, they orient themselves in the dark by smelling us, and the nose of the mosquito is the antennae. So we were trying to figure out what compounds they use. Why are we doing this? I was just telling you that malaria is killing so many people in the world, and what we're trying to develop is traps. Simple traps that you can put around in the villages in Africa that will trap mosquitoes before they actually fly into a house and bite a person. So we mimic a human being. That's what we're trying to do. We're trying to mimic a human being, and in that way trap mosquitoes and try and see if we can stop transmission of malaria. So my research, I only had 4 years during my PhD, and with all these hundreds of compounds, how on earth am I going to find out which are the important ones? So I put a guy that I know in the lab, I put him in a bag, and I started tapping all the smells from him. You can see here this pipe. So I was collecting all the smells, and one of my colleagues was breathing in an apparatus so that on an adsorbent I could actually collect all the smells from the breath. But as I said, these are hundreds of compounds, so this was going to be really hard to figure out what it is. And then one afternoon, something happened. I was in the library, and I was going through very old books. And in one of these books, I found this article. And it was an article written by a Brit who was working in Uganda, in Africa, and he was studying where mosquitoes were biting on the naked bodies of children. Naked bodies of children. So he had children standing up, he had children sitting, and children laying down. And he observed that this mosquito had a very strong preference for biting on the face. And that intrigued me. So we set up an experiment ourselves whereby we put a naked volunteer in a very large cage, and inside that cage we released one by one mosquitoes to see where they were biting on the body of that person. We really did. We really did. I've got a very dry mouth. I need something to drink. So, putting a person in a cage, and then for 3 minutes that mosquito could select a bite on the body. We told the person not to move. And we found some remarkable differences. I'm showing you from 3 different species, one fell off. I'm showing you 3 different biting patterns. This is the Dutch malaria mosquito, and you can see it had a very strong preference for biting the face. In fact, 20 out of 100 bites, which you can see here, 100 bites, 20 of them, the mosquito actually landed on the nose and was biting on the nose of that person. Okay? For the African malaria mosquito, which was my target, we found a very strong difference. Here there was a very strong preference for biting the ankles and feet of that individual. And so I got to the smell of human feet for this mosquito. And that, of course, is something that we should have known all along, because they're called mosquitoes, you see. Very simple. In any case, when I then started reading more, I started doing literature research on foot odor. And fortunately, we know a lot about foot odor because of these individuals that were left standing up. Because they want to use products that quench their foot odor. So they go to the pharmacy and buy stuff that they can put in their shoes. So industry knows a lot about the smell of human feet. And so I wanted to know the same thing. And I started reading. And then I came across some remarkable statements. One of these was that cheese smells after feet rather than the reverse. Think of it. Think of it. And then in Holland we have the word tenenkaas. And tenenkaas is, we refer to that yellow stuff that you have in between your toes. You have that also in Switzerland, don't tell me, come on. Okay, so tenenkaas, toes and cheese. It literally means toes and cheese. And then something remarkable. Bacteria involved in cheese production may have originated from human skin. Wow. That was a statement. That really stuck in our minds. And together with Ruud de Jong, another biologist, we were working together, we then suddenly came to some crazy idea. And we said, well, maybe then, if we really use some of the cheeses that really smell really badly, that smell after human feet, maybe we can attract African malaria mosquitoes with that. Of course, we didn't tell our colleagues, because they would declare us completely crazy. I didn't tell my supervisor. But we went to a local shop in Holland, and we said to the lady behind the counter, do you have cheeses that smell like feet? And she said, of course I do. I've got this one, I've got that one, I've got a Gruyere, I've got a Limburger, She had many cheeses, so we bought them all, and then we went back to the lab and we started doing our research. And sure enough, we managed to attract, with a tiny little piece of Limburger cheese, African malaria mosquitoes. An amazing accomplishment. We couldn't believe that this actually happened to us. And so you get really crazy about it and you think, oh, we're going to solve the world's problem now. And so we tried to figure out what exactly it was. Why was there this connection? And the connection actually turned out to be the bacteria. The bacteria that are used for inoculating the cheese to give it its very specific flavor are very closely related to bacteria that we have on the human foot. On the foot, we've got Brevibacterium epidermidis. On the cheese, we use Brevibacterium linens. The same bacteria producing the same smells. And of course, we send off our paper. Limburger cheese is attracted for the African malaria mosquito Anopheles gambiae. We send our paper to Nature. We thought, this is such big science. We have to publish this in Nature. And Nature, of course, rejected the paper. Okay? But then we published it in Parasitology Today. And it was published on the 1st of April, 1996. So our colleagues, I'm not kidding you, I'm not joking you, our colleagues around the world thought that this was a very nice practical joke. As it is, we've progressed tremendously. The world press, they love the story because you've got... I gave you $10, eh? Okay? Because the world press, they love the story. Here's a disease that kills 1 million people every year. It's food and it's our smelly feet. You take that combination, you've got a perfect story. It was published from Vietnam to Argentina and everywhere in between. Fantastic. Now, Bill Gates also heard about this. And Bill Gates in 2005 said, so where are you guys with this research? We said, well, you know, we're always short of money. And to do some more research, we could need some more money. And Bill said, okay, I'm giving you 8 million. Whoa. Whoa. So we got 8 million from the Gates Foundation. And we started doing field work in East and West Africa with all these traps. And eventually, in 2010, we published a paper now, with which we have shown that 9 of the compounds, 9 of the chemicals that you find on the flavor of Limburger cheese are actually 2 to 3 times more attractive to mosquitoes than humans in Tanzania. So what started as a practical joke, an interesting piece of research, actually turned out into a real-life solution for the problem of malaria. Okay? Yeah, thank you. That's it. Thank you very much. And I got my money back. Applause. Okay. Perfect.
Are you finished?
I'm done.
Oh, he's done. Well, a hand for Barton. Questions, please. Raise your arm and wave it if you have a question.
Whoa.
Repeat the question.
The question is, do you use real Limburger cheese or the synthetic version of it? Short answer is, we started all the work with the real stuff, with the Limburger. And by the way, there were other companies like the Bayer company in Germany that started doing their own research on cheeses. So they copied everything that we were doing. But eventually we had chemists analyze that what we call the headspace, the aroma that comes off the cheese. And we figured out that there are 12 fatty acids in there, volatile fatty acids. We then started working on synthetic blends of these fatty acids, and that's what we're using in the field.
Next question.
Which kind?
He said, we have in Switzerland a kind of cheese that can kill mosquitoes. I don't think that's a question. It sounded like a statement.
And what's the name of that cheese, if I may ask? What? What's it called?
Comes from center mountainous Switzerland. And they have not so much mosquitoes and they've never seen malaria there.
Any comment on this?
No comment.
Okay. We can obtain some of that here in the city, in a cheese shop? Yes. Well, we have to get to a cheese shop.
We'll buy it.
Yeah.
And I'll take it to Africa with me.
Yeah.
But what is very strange, meet in Nepal in the jungle, the Taru people, the people are completely protected against malaria. They fish with elbow. And then come the DDT, and the DDT, they invented in Switzerland, have killed the society of the Tarus in Nepal.
Perhaps the two of you can talk afterwards over a piece of cheese.
But it's true, DDT was invented in this country. Well, it wasn't. DDT was first synthesized in 1874 by an Austrian student in Vienna. Paul Müller used it here at the Ciba company in 1939. But that's detail. No problem.
You can continue this fight later, gentlemen. Okay, one final question. In the back there. You, who's turning around looking behind you, yes.
How much
An awful lot. And you know what?
Repeat the question.
Oh, how much Limburger cheese can you buy for $8 million? A lot of Limburger cheese. Mind you, this kind of research is you're pumping up money very quickly. It's very costly because we're working with. This was a collaboration of some 6, 7 institutes around the world, 2 in Africa, 4 or 5 in the US. There was an institute. The thing is, in the United States, there's only one place where they produce Limburger cheese. Here in Europe, we produce it all over the place, but in the US, they figured out this is not good for mosquitoes. So.
Bart Knowles.
Thank you.
And now it's time for our final song of the night. This is from a different Ig Nobel opera. This opera was called Chemist in a Coffee Shop. It took place in a coffee shop. An arrogant chemist came in and discovered to his surprise that the people who worked there, the baristas, knew a surprising amount about the chemistry of coffee. Please welcome one of these baristas who will sing to us about the chemical ingredients that make that thing we call coffee. Please welcome again accompanist Alice Martelli and our singer Maria Ferrante.
Oh
Maria Ferrante, Alice Martelli. It's time for the final speaker of the night. Kees Muliker was awarded the Ig Nobel Prize in Biology in the year 2003. He made a discovery, a most unexpected discovery. He was not looking for something, but he noticed something and paid close attention and later wrote a scientific paper, and it came to our attention. He has achieved a special and large measure of fame in many parts of the biology world, and in fact in many parts of the world in general. His is an unusual story. He has come here today from Rotterdam, the Netherlands, to tell us about it. Please welcome Kees Muliker.
Thank you. This is the Natural History Museum in Rotterdam, where I work as a curator. And it's a new building made in 1995, and birds had a problem with it. Birds have a problem with glass. They don't see it. They don't see it as a barrier, and they fly into it, and they get killed. Now, I'm a curator at the museum, at the Natural History Museum, but I was still annoyed by all these casualties among birds. I mean, I'm a lover of nature, I prefer them alive. But we tried to solve the problem with putting these stickers of birds of prey on the glass, but it didn't help. So, this continued, and I developed an ear for these birds who got killed against the glass. I mean, I could hear, this is a blackbird, this is a sparrow, this is a pigeon. So it became kind of fun to collect all these birds and give them their place in the collection of the museum. But on June 5th, 1995, I heard a very loud bang against the glass of my office. And I looked out of the window, I saw this. The bird that's lying on its belly over there was a duck, a mallard duck, but next to it was a live duck. And then this happened. The live duck mounted the dead duck and started to copulate. Well, I'm a biologist, I'm an ornithologist. I said something's wrong here. So, one is dead, one is alive. There's copulation, must be necrophilia. I took a close look at the ducks individually. I saw both of them are of the male sex. Homosexual necrophilia. So I took a chair, I took my camera, I took a notebook. I started to observe this behavior. I mean, it was new to me. I'd never heard about it. I could do so because this behavior took 75 minutes. After 75 minutes, I'd seen enough. I was getting hungry. I wanted to go home. So what I did, I went out to... first, of course, I put the notes back into my office. These are the original notes I made then. So I went out, I collected the duck and checked the sex. And here's a rare picture of a duck's penis. So it is indeed of the male sex. I mean, it's a rare picture because there are 10,000 species of birds in the world, only 300 have a penis. It took me 6 years to decide to publish this observation. I mean, it's a nice story to tell at the coffee machine or at birthday parties, but to share it with your peers, it's a different story. But in the end, my friends and colleagues urged me to publish it, so I published the first case of homosexual necrophilia in the mallard duck. Here's the situation again. A is my office from where I observed it. B is where the duck hit the glass, and there's supposed to be C. That's the location from where I watched it. And here are the ducks again. Well, probably you know this as a scientist. When you publish a specialized paper, only 6 or 7 people read it, and that's it. So everybody's happy with that. And but then I got a message from Mark Abrams. He wrote me an email, can we have a confidential discussion about your duck paper? Okay, so we had a confidential discussion about my duck paper back in 2003, and he explained to me that I'd won a prize. I'd won the Ig Nobel Prize. I'd never heard about this prize, but I accepted it. It was a good thing, making more people interested in science using humor. So I went to Harvard, had my 60 seconds of fame, and then my life changed. People started sending me all kinds of duck sting. All kinds of duck. I have a large collection. It's very diverse. But on the other hand, people also realized I was interested in remarkable animal behavior, and they started sending me their observations. And I can honestly tell you, if there's an animal misbehaving on this planet, I know about it. And I'll give you some examples as long as the bell doesn't ring too long. Here's a frog trying to copulate with a goldfish. This is back in the Netherlands in 2011. It was in 2008 in Montana, the United States. It's a moose trying to copulate with a bronze statue. Well, these are the mistakes. This is a case of necrophilia in barn swallows. This is Hong Kong, 2004. Here are bank swallows in Canada. Feral pigeons in Rotterdam, the Netherlands. Here are cane toads in Australia. Well, frogs and frogs and toads are a different story. I mean, they copulate with almost everything when they're in the mood. But what's special here is the position. The missionary position is very, very uncommon in nature. Yeah. So what's the function of this behavior? Of course, I mean, if you have sex with a dead person or a dead animal, it doesn't lead to any reproduction. Well, it does. I mean, there was a recent paper published from people from Brazil who found functional necrophilia in this tree frog in Brazil. What the frog does, it jumps on the dead frog, the dead female, and squeezes the eggs out of the corpse and then fertilizes it. So there is some function in this behavior. Here are turkeys in Wisconsin, the U.S. This was taken on the premises of a juvenile, a prison for kids. It took all day, and the prisoners had a good time. This is the second case of homosexual necrophilia in mallards. It was photographed in Oxford 2 years ago. Here he goes. I wrote a book about all this. It's called The Duck Guy. If you translate it, it will probably come in different languages soon. And in this book, I formulated a theory about necrophilia in the animal kingdom. And my theory is that this only happens when death is dramatic and in a position that is normal for copulation. I mean, my duck was laying on its belly, and ducks have sex on that way. There's a famous case of a squirrel who got involved in necrophilia, and it was laying on its side, and they have sex on their side. But then these pictures were sent to me only last year, and look at here. That duck was there for 3 days, and it's laying on its back. So there goes my theory of necrophilia. Sorry to say. I have to think about it again. So I'll conclude by inviting you to that Duck Day. It's on June 5th every year. It's coming close. It's in less than a month. We joined together at the Natural History Museum in Rotterdam. The duck comes out of the collection, and we try to discuss new ways to prevent birds from colliding with glass. And maybe you don't know this, but this is one of the most dramatic causes of death in birds. Only in the US, 1 billion birds die every year, and this has to stop. There's always lots of press, and when it's all over, we go to the local Chinese restaurant to have the 6-course duck dinner. So please join us for that Duck Day in Rotterdam in a couple of weeks. Thank you.
Does anyone dare to ask a question? Raise your arm if you do.
And why so much Dutch are so brilliant and so crazy, so much crazy scientists in Netherlands?
It must be something in the drinking water.
Okay. Next question. I know you've been waiting, some of you, years to ask Case questions about this famous case.
Well, there's one thing... Oh, please.
I think your original research was about prevent birds to killed by glass and the progress in this area.
Yeah, well...
Could you repeat the question?
Oh, yeah, well, I started to wonder how could I prevent birds from colliding with glass. And then it turned out to be a gold mine, this museum. That's right. Yeah. But I do try to think about ways to prevent it. And there are ways. There are manufacturers of glass who use ultraviolet coating that we don't see but birds see, and that solves the problem completely. But it's I think 10 times more as expensive as normal glass. So probably never make it in construction. Yeah, please.
Do you see the same behavior if you actually anesthetize the duck and just lay there like
Okay.
Repeat the question.
Yeah, well, yeah. So the question is, well, did you experiment with this? No, I didn't. I'm tempted to do this, but well, I live in a big city, and if people know me there, and if I, you know, no, I don't think it's a good idea.
Well, the question was specifically, did you experiment by anesthetizing the duck?
Okay.
Did you?
Okay, yeah. Well, there are enough dead ducks. They don't need to be anesthetized. Yeah.
Okay, and another question over here.
So from here, I couldn't help but notice the unusual shape of the duck's penis.
Yeah.
Anatomically, how does that work?
Everyone hear that question?
Especially with reference to the homosexuality.
Mm-hmm. Yeah. Well, the anatomy of the duck's penis is quite extraordinary. It has a corkscrew structure. And the good thing is that the vagina, the female parts, have a corkscrew shape that is in the opposite direction. And you all may know that ducks have rape as their reproductive strategy. And it looks very bad for the female ducks, but in the end, because of they allow which male may enter her vagina by relaxing the muscles. And if it goes wrong, there are all kinds of dead ends in the vagina. So in the end, she will choose the right sperm for her eggs. Yeah. So it's really nice, and I think anatomically. Yeah. Okay. Yeah.
Please thank Kees Moeilijker. Well, that's everything that we brought to show you, at least that we dare to show you tonight. I would like to thank all our speakers. I first want to thank our two-timers. Thank you very much. Please stand and take a bow. And could all of our speakers and musicians please come up here and take a bow? Maria Ferrante, Alice Martelli, Stefan Ross, Stefan Bolliger, Bart Knowles, and Kees Moeilijker. If you'd like more information, you can get more information about all of this on the website, improbable.com. If you know of somebody who you think should get an Ig Nobel Prize, please let us know. This is how we learn about most of the people who win prizes. Somebody, usually one person, notices something, just as Kees noticed the duck, and they tell us. So if you tell your friends, that's great. But please, when you notice something, tell us too, so that some deserving person can get the Ig Nobel Prize that they richly deserve. Thank you very much to the University of Geneva. Thank you to CERN. Thank you all for coming.